Imagine an invisible teacher standing behind every AI system you interact with, whispering the right answers, correcting mistakes, and shaping the model's intelligence. This teacher has a name: supervised learning, the quiet force powering everything from email spam filters, credit card fraud detection, medical diagnosis tools, language translators, image recognition, to your favorite recommended for you playlist. Today, we're diving not just into what supervised learning is, but how it actually teaches machines to think, why it works, where it fails, and how you can use it in real-world applications. The core idea: machines learn from examples. At its heart, supervised learning is simple. You give the model examples, inputs paired with correct outputs, and it learns the pattern. Show millions of labeled cat images, and it learns what a cat looks like. Give house prices and property attributes, it learns how to predict price. Provide sentences with sentiment labels, it learns how to detect emotions. Formula in plain English. Here's the question, here's the answer. Learn the mapping between the two. This mapping is what becomes the model. Classification versus regression, the two pillars. Classification predicts categories. Examples: spam, not spam; malicious, safe; dog, cat; horse; positive, negative review. Real-world example: a bank preventing fraud. Input: transaction details. Output: fraud or not fraud. The model learns patterns like unusual locations, sudden large withdrawals, etc. Regression predicts continuous values. Examples: house prices, weather, temperature, stock price trends, fuel consumption. Real-world example: predicting the price of an Uber ride before you book. Distance, time, demand, traffic predicts price. Under the hood: how supervised learning works. Breakdown in simple steps. Step 1. Collect data, the foundation. Example: 10,000 labeled medical images. Step 2. Split data. Training set teaches the model. Validation set fine-tunes it. Test set checks performance on unseen data. Step 3. Choose a model type. Popular supervised learning models: linear regression, logistic regression, decision trees, random forests, gradient boosting, support vector machines, k-nearest neighbors, neural networks. Step 4. Train the model. The model adjusts internal parameters to minimize error. Example: in linear regression, it adjusts weights to get the best fitting line. Step 5. Evaluate. Metrics: accuracy, precision/recall, F1, score, RMSE. Step 6. Improve through hyperparameter tuning. Cleaning data, adding more labeled examples, feature engineering. Everyday examples: how supervised learning sneaks into your life. YouTube recommendations predicts what you'll watch next. Input: your viewing habits. Output: probability you'll click a video. Medical diagnosis AI. Images plus expert labels. Trained system detecting tumors. Email spam filtering. words and label, pattern recognition over time, smarter filtering, voice assistance, understanding commands. Thousands of voice clips labeled with actions like play music or set alarm. Agriculture. Classifying crop diseases from leaf photos. Finance. Regression predicting customer lifetime value. Where it fails, the weaknesses. Needs a lot of labeled data. Imagine labeling 1 million images manually. Can learn human biases. If the data is biased, predictions will be too. Overfitting. Model memorizes noise instead of learning patterns. Not good at novel situations. If the model is trained only on sunny images, it fails in snow. Supervised learning in action, practical mini demo. Here's a small data set of houses. Each row is a real estate listing, and the price is what we want to predict. Our goal is simple: predict the price of a house based on its features. Let's begin with just one feature: square footage. As the size increases, the price usually goes up. Linear regression tries to capture this trend. The model starts with a random guess. This line is nowhere near accurate, but it will improve. The gap between each point and the line is the prediction error. Linear regression tries to shrink these gaps. With each step of training, the model adjusts the line, minimizing the error using a process called gradient descent. Think of it like rolling downhill to the lowest point. And finally, the algorithm finds the best fitting line, the one that captures the underlying trend between size and price. It learns a simple formula, a slope and a bias, that lets it estimate house prices. So if we enter a new house, say 1,200 square feet, the model predicts around $250,000. In real models, we don't rely on one feature. The algorithm also looks at bedrooms, age, and location, each adding or subtracting from the final price. These weights show how strongly each feature affects price. Put everything together, and the model predicts the final price based on all the features. This is linear regression, simple, powerful, and one of the most widely used tools in supervised learning. The future of supervised learning. With synthetic data, self-training, and AI-labeled data, supervised learning is becoming more powerful, more scalable, and more accessible. It's the bridge between humans teaching machines and machines learning to teach themselves. If you found this video helpful, hit the like button, subscribe to the channel, and let me know in the comments which supervised learning examples surprised you. Thanks for watching, and I'll see you in the next one.